Today, we're diagnosing P0072 on a Silverado 2500 diesel. This same ambient temperature circuit check can apply to related faults, but this episode stays focused on P0072. In plain terms, P0072 points to the ambient air temperature sensor circuit reading low voltage. The ECM watches that ambient temperature sensor, converts the voltage into a temperature value, and may use default values when the fault sets. The driver may notice the displayed outside temperature updates slowly while parked. An air conditioning operation can be affected. Broadly, we're thinking about a possible sensor issue, connector terminal condition, signal circuit fault, low reference fault, or after the circuit proves out a possible ECM-side issue. For P0072 specifically, the code sets when the ambient air temperature sensor signal is greater than 88 degrees Celsius. Start with the basic system checks and follow a structured diagnostic approach. With the ignition on, or the vehicle in service mode, check whether this ambient temperature circuit code is current. If it is set, go straight into circuit testing. If it is not set, look for any other ECM or temperature-related codes first. If other codes are present, check what they mean before chasing this one. If there are no other codes to handle, let the vehicle cool completely to ambient temperature. Then compare the scan tool intake air temperature sensor parameter to actual ambient temperature. It needs to be within 15 degrees Celsius, 27 degrees Fahrenheit. If it is not, handle the intake air temperature diagnosis first. If the intake air temperature value is within 15 degrees Celsius, 27 degrees Fahrenheit, compare the scan tool ECM ambient air temperature parameter to actual ambient temperature. That value also needs to be within 15 degrees Celsius, 27 degrees Fahrenheit. If it is outside that range, move into circuit testing. If it is within range, the check is okay at that point. When available, the ECM ambient air temperature calculation reset can help the displayed temperature update more quickly. For circuit testing, turn the ignition and vehicle off and let all vehicle systems power down. It may take up to 2 minutes before a ground or low reference continuity test is accurate. Disconnect the B9 ambient air temperature sensor connector. Test between low reference circuit terminal B or terminal 2 and ground. You want less than 10 ohms. If that test is 10 ohms or greater, disconnect the K20 engine control module connector and test the low reference circuit from terminal B or 2 at the component harness to the other end of the circuit. That test should be less than 2 ohms. If it is 2 ohms or greater, repair the open or high resistance in that circuit. If it is less than 2 ohms, replacement of the K20 engine control module is supported at that point. If the low reference to ground test was less than 10 ohms, turn the ignition on or put the vehicle in service mode with the ambient temperature sensor still disconnected. Watch the scan tool ambient air temperature parameter. It should read less than negative 34 degrees Celsius, negative 30 Fahrenheit. If it reads negative 34 degrees Celsius, negative 30 Fahrenheit or warmer, turn the ignition and vehicle off, disconnect the K20 engine control module connector, and test the signal circuit terminal A, or terminal 1, at the component harness to ground. That test should show infinite resistance. If it shows less than infinite resistance, repair the short to ground on the signal circuit. If it shows infinite resistance, replacement of the K20 engine control module is supported at that point. If the scan tool ambient air temperature parameter is negative 35 degrees Celsius, negative 31 degrees Fahrenheit, or colder, connect a 3-amp fused jumper wire between signal circuit terminal A, or 1, and low reference circuit terminal B, or 2. Now the scan tool ambient air temperature parameter should be greater than 143 degrees Celsius, 290 Fahrenheit. If it is 143 degrees Celsius, 290 Fahrenheit, or colder, turn the ignition and vehicle off and remove the jumper. Disconnect the K20 engine control module connector. Then turn the ignition on or put the vehicle in service mode. Test between the signal circuit at the component harness and ground. You want less than 1 volt. If it is 1 volt or greater, repair the short to voltage on the signal circuit. If it is less than 1 volt, turn the ignition and vehicle off and test the signal circuit end to end. That circuit should be less than 2 ohms. If it is 2 ohms or greater, repair the open or high resistance. If it is less than 2 ohms, replacement of the K20 engine control module is supported at that point. If the jumper test drives the ambient air temperature parameter to 144 degrees Celsius, which is 291 degrees Fahrenheit or warmer, apply dielectric grease to the connector terminals and reconnect the B9 ambient air temperature sensor. Then reproduce the operating conditions for the code and verify whether the repair corrected the DTC or symptom. If it did not, the next move is to test or replace the B9 ambient air temperature sensor. If it did correct the issue, that part of the diagnostic path is okay. For the static sensor test, place the B9 ambient air temperature sensor in a stable temperature-controlled area for at least 10 minutes. Measure resistance between sensor signal terminal A, or 1, and low reference terminal B, or 2. Compare that reading to the correct ambient air temperature sensor resistance specification. Do not guess at that comparison. Have the correct resistance specification in hand before condemning the sensor. If the reading is not in the specified range, replacement of the B9 ambient air temperature sensor is supported. If it is in range, the sensor test is okay. After any repair, keep verification separate from the circuit testing. Verify the repair and confirm the code stays gone. The code clears when the setting conditions no longer exist, so confirmation matters after the repair. The takeaway on P0072 is simple. Prove the temperature values first, then prove low reference, signal response, shorts, opens, and connector condition before condemning a module or sensor. For more diagnostic training, visit stepdiagnostics.com.